Again, pardon the new bandage on my nose. I had another basal cell removed on Friday, so please don't let that be a distraction. Let's get on to bigger and better things. Today we're going to be talking about radio halos in general and polonium halos specifically. Now I'm going to explain what those are. When rock is in its molten state, especially granites, a radio particle will fall into that molten rock, and as the radioactive particle, usually uranium, decays, it will shoot off alpha particles in all different directions, and it forms like a shell. And if you remember your geology, a line segment coming out from a single point to a certain designated area is a sphere. And then a sphere, if you cut it in half, that's a circle. So uranium, as it decays into uranium-238, decays into thorium-234, which decays into protactinium-234, and on down the line. 14 steps later, you come to its base and stable element, which is lead-206. So as the uranium is decaying, and the uranium-238 decays into thorium-234. So that shoots out a certain area, a certain length from what is essentially the nucleus, and that forms a shell. And then you'll have, it decays into protactinium, which shoots out into different areas, and that forms a shell. And so you have essentially a shell within a shell within a shell, or a circle within a circle within a circle. And here's some electron microscope pictures of what these radio halos actually look like. And as you can see, there's concentric circles or spheres, and you'll notice the ones that are farther out, those are the more radioactive elements. The ones closer to the nucleus, those are the less radioactive elements. So when uranium-238 decays, that's like the mother element, and it gives birth to the daughter element, which is thorium-234, and then that daughter element becomes the parent and gives birth to the daughter element of protactinium-234. Then it goes on and on and on down the chain towards lead, but in that chain, bismuth-214 is born, you may say. And bismuth-214, that daughter element, then becomes the mother element and gives birth to polonium-214. So each one of these elements that I was just rattling off, they have their own ring, and they're formed within the molten granite. Now, how you get these guys out in order to look at the concentric circles is you take the granite and you crush it up, and you'll find these particles in the mica, the biotite mica, which is a real flaky, kind of a clear glass. You can peel it off real thin sheets. You can hold it up and see light coming through it like a stained glass window. In that biotite mica, the black mica, that's where these little guys are found. So you crush it up, get the mica element out, put it in an electron microscope, and you will see these. Now, what is the big deal about polonium-214? The half-life. In order for a radio halo to form, it has to form within the molten rock, and it has to be timely enough that it is imprinted and hardened so that the imprint will be left. Half-life is the amount of time it takes for a radioactive element for half of it to decay. Polonium-214 has a half-life of 164 microseconds. You heard that right. The half-life of polonium-214 is 164 microseconds. That's faster than it takes to snap your fingers. So that means that in order for these polonium-214 halos to form and be imprinted in the rock and the mica, they have to instantaneously cool. They're molten and then, bam, they're cooled. Now these things are, if they were found 2 or 3 places around the world, this would be an anomaly. But these things, polonium-214 halos, are found by the trillions all over the world in the basement rock of the Earth's crust, the granite. How did they appear? 164 microseconds for this to imprint and embed in the rock? Want to know more? Click the link.